Hello, everyone. Good morning or good noon, exactly. Welcome to the first edition of a battery startups launch of BEPA. This will be a new monthly webinar series with the aim to allow battery startups in the European battery space to showcase their products and innovations and their activities, and also present the business opportunities that their technologies offer. And this is also, sorry, this is also part of our efforts to foster collaboration and synergies between all the stakeholders of the European battery ecosystem. And we have many webinars lately going on, and almost every week we've got a webinar coming up on different topics around the battery sector in Europe. And we encourage you to follow our activities on our website or social media to know what's coming. So today we will have 5 startups presenting themselves, each with 10 minutes, and you are of course welcome to ask them any questions or comments. So to go over a few practical aspects before we get into the presentations. Thanks. So as a rule, the meeting is recorded. And so the recording will then be made publicly available on our YouTube channel. So you can also share with your colleagues or any other stakeholders that you believe will be interested in looking at it and are not available now. During the discussions, so during the presentations, you are of course free to post comments and questions in the chat for the speaker, and they will have a bit of time to address any comments and any questions. If you have any technical issues, please send a message in the chat and we'll try to help you. And also when it is not your turn to speak, please keep your microphone and camera deactivated. Although for the attendees, of course, you will not be able to activate your microphone and camera. So to intervene, please do so in the chat. And of course, as I said, this will be a monthly webinar series, and I can already say that the next edition will be on June 18th at the same time from 12 to 1. And so don't hesitate to register. We'll put the link in the chat as well now and at the end of the session. And there will be 5 new startups presenting themselves on that date. So without further ado, here today for today's agenda. So we will start with Philip White, who's already ready to get in. He is a public affairs and business development manager at Circunomics. And Philip, I leave now the floor to you.
Okay, thank you, Timothy. So you should see my screen now. Can you see it?
Yes, perfect. You can go ahead.
Okay, so thank you for the introduction. My name is Philip. I'm Business Development Manager and Public Affairs at Circunomics, the world's leading intelligent and analytic-based battery marketplace for second life and recycling to create a circular lithium-ion battery economy. I have a short video for you. You can see it here.
In our world of rapid innovation, new challenges call for sustainable solutions. Today, the e-vehicle industry is booming. But what will happen to the lithium-ion batteries after they reach the end of their first life? We at Circunomics are dedicated to preventing any lithium-ion batteries from becoming waste by creating a circular battery economy. Using our predictive analytics tool and B2B marketplace, you'll find the best second life application for your batteries that will effectively utilize their remaining capacity and create additional revenue for you. Once the batteries reach their end of life, recyclers will close the loop. Join us in making every battery circular.
Okay, so some quick facts about the company. The vision of Circunomics was to establish a true circular battery economy to maximize each stage of the battery life cycle. The company was founded in 2019. The co-founders are Jon Bahn here on the left and Felix Wagner on the right. The headquarters is in Mainz in Germany, and we just closed our Series A funding in December with 8 million. And in the last years, we traded already in the gigawatt-hour range of batteries on our marketplace, and now we have several gigawatt-hours of batteries available. So our global footprint, we started in 2019 in Europe, and since this year we are also in North America, and we are looking into Asia in the next years. We are 30 people from 15 different countries, and we are also hiring. So if you're searching something new, we have 7 open positions at the moment. So here you see some of our investors. The company Schaeffler just joined in the last funding round. So they are a big automotive supplier in Germany. Then we have GET Fund, the Green European Technology Fund. They have a lot of sustainability criteria to invest in. Then we have SKTS, the big recycling company, and we have Orlen, energy company from Poland, and we also have Peter Mertens, former CTO from Audi and Volvo, and we have Bram Schott, the former CEO of Audi. So here, what's the historical approach of the OEMs? They build their cars, then they sell their cars, and then they don't really know what to do with the cars, and most of them are maybe exported. But with electric mobility, the OEMs are missing out of substantial revenue of around 1.5 billion in 2030 by the second life industry sales of their batteries. So what's the challenge? The e-vehicle battery is the most valuable part in the car, and it also accounts for nearly 70% of the life cycle carbon emissions. What's the solution? Circular approach through second life usage to lower the carbon footprint, but also to increase the profitability. So this is now the circular approach. The cars are manufactured and then sold, and then the battery has the first life in electromobility, and then the batteries can be used again in second life in energy storage, and after that they can be recycled and the loop is closed. So here, these are the capabilities. You see a study from McKinsey from 2021. How many batteries, how high is the demand for energy storage in 2030? It's around 120 gigawatt hours, and the same amount of batteries will come back from mobility around this year. So the whole demand can be met by the batteries from electromobility. So here are different examples for second life applications. So depending on the SOH, you can do different things with the battery till the end. You can also still use them for backup power until the SOH is too low, and then you go to the recycling. So what are the solutions we have? We have different products for the first life and the second life, and also for recycling of the batteries. So these are our products. We have battery analytics. So we use the historical data of the battery to do second life prediction, and also to allow the life cycle planning of the batteries. And then we have a B2B marketplace. You see the batteries fall into the funnel here, and then depending on their condition, they can be used for second life application or for recycling, and they can be sold on the marketplace. So here you see battery analytics. You can use it for remote monitoring of your fleet. For example, if you have electric trucks or something else, we have digital twin technology and state of health prediction with 90% accuracy. And you can also predict the residual value of your batteries. So here you have the first life and second life simulation. You see how many cycles are left in the battery. If you use it, for example, you can choose home storage, standard cycling, and grid balancing. And depending on the use case, the remaining cycles are different. So now we come to the marketplace. So you see here, okay, it's possible to sell cells, modules, or also packs on the marketplace. In the future, you can also sell a complete BESS containers there, but you can also sell black mass there as a recycling company, or as a recycler, you can buy black mass. So there are different roles on the marketplace: seller, buyer, and recycler. And you can't just register as a private person. So we screen every company that wants to register, and we verify that this company is really existing and not some mailbox company. So here you see the whole loop. We start with the raw material. The batteries are manufactured, And then the first life of the battery can be monitored by our battery analytics, and we predict how long the battery will last in the first life. And then you have a good planning when you want to sell your battery for the second life. You can use the marketplace to sell it to energy storage company. They can use it in the wind farm, for example, here. And then they know with our analytics how many years the battery can be used. And then after the end of the second life or end of life, the battery can be recycled and the loop is closed. Okay, so summary, why second life usage? We want to lower the lifetime emission of the batteries. We want to increase circularity, and also we increase the revenues and savings, and therefore Circonomics is providing the solutions. So these are my contact details, and there are already some questions in the chat. So I try. Okay, so I start with the last one. Which chemistries are covered? So all chemistries are covered at the moment. We always talk about lithium ion, but in the future there will also be some other chemistry like sodium ion. So what's the business model? Yeah, we are like the broker in between. So we get some commission. One is the seller of the battery, one is the buyer of the battery, and then we get commission in between. And also for this analytics, we have different price models. You can pay per kilowatt hour or per year. This is negotiation on how is your business case. And we don't provide guarantee on the battery because we are not the seller. But some of the sellers say, okay, the battery is still in good shape. We provide another 5 years of guarantee, for example. So this is always in negotiation with who is selling the batteries. And at the moment, we have a lot of batteries that are still state of health 100%. So we don't call them second life batteries, we call them second chance batteries. So they were produced for automotive, but then they were lying in the shelf for too long and they can't be used anymore for new cars, but they are still 100% SOH. So they can be used for energy storage, and they are in good shape and they have good price, but still 100% SOH. What is the estimated kilowatt hour price for these batteries? And can they compete with cheap LFP from China? So this is always depends on the seller, because the seller defines the price. And when they can't sell the battery, they have to go down with the price. And if the cheap LFP is coming from China, they have to check, okay, how low can I go with my price to still sell the batteries? So this is, a good question.
Sorry, Philip, I'm going to have to stop you here because we have to move on to the next presentation. I would encourage you to answer them in the chat, or for those who want their questions answered, don't hesitate to send an email to Philip directly so that he can answer you later. We'll now move on to a presentation from Daria. So Daria is the head of business development and ESG at Geyser Batteries. So please, Daria, the floor is yours.
Hi, everyone. Thank you so much. Let me try to share my screen. I apologize. You'll have to see my entire screen for a moment. Right. Can you see right now my screen? I hope yes.
Yes.
Perfect.
Yes.
Thank you so much, Timothy. So, good afternoon once again. My name is Daria Giovanacci, and I'm indeed leading business development and ESG, and also a little bit of EU relationship management work at Geyser Batteries. So, Geyser Batteries is a Finnish startup established in 2018 to commercialize a new generation of high-power batteries based on our proprietary aqueous electrochemistry. So we are here to develop what we call the greenest and cheapest megawatt minute to stabilize the renewable power grid. I'm sure all of you are aware of the problem that lies with the switch to renewables, but just let me give you a little bit of a background to this problem, just to set the scene a little bit. So in the old era, we used to use the fossil fuel naturally, which was expensive and dirty, but our power grids at least were stable and flexible. That was at least the benefit of it. Now, as with the proliferation of renewables, the grids become cheaper, cleaner, but the energy generation is becoming less and less stable and less centralized. So we end up with ever more frequent periods of grid imbalance due to this kind of excess energy supply. There are existing solutions that can help with this issue. So hydropower, Power-to-X, and low-cost, long-duration storage can help deal with these intermittencies, but they all share one issue, one feature. They cannot respond to the highly volatile energy peaks fast enough. So basically, we have this time period which is simply not covered fast enough by this existing solution. So grid operators need fast-acting energy storage capable of bridging this critical minutes-long gap until these great but slower technologies can actually kick in. And this minutes-long gap is what is perfect for geyser batteries for our electrochemistry. So basically, what we are doing is we are offering the ideal solution for cheap and green megawatt minute because our batteries can respond in less than 1 millisecond, can be fully charged in up to 3 minutes, can store up to 5 times more energy than supercapacitors, and last hundreds of thousands of cycles. So basically what we are doing is offering local stability, which is so much needed to make our renewables cheap again. Also, we produce the batteries from sustainable and abundant materials on low capex facilities, which of course adds this to the low cost feature of our solution. Basically, what we are doing here is that we are here for a teamwork to support the grid with affordable, sustainable, and powerful solution to boost the stability of existing assets. By doing that, we also help to add the revenues through the ancillary services, energy trading to the existing assets, and of course, save on the costs on grid connection to help reduce the wear and tear in the certain applications, and of course, avoid these grid imbalance fees which exist. So let me just briefly guide you through the technology itself. Geyser batteries technology is based on 3 key technical features. So we use aqueous electrolytes, bipolar cell design, and of course the proprietary and patented electrochemistry. Pure water as an electrolyte allows us to produce batteries cheaply, makes them fire safe, and also makes them very fast to respond. The bipolar cell design allows to stack the cells directly onto each other like a sandwich, thus decreasing the material usage and the cost of utilizing casing, so much less materials are utilized. And also the bipolar cell designs allows to boost the power performance of the battery. And finally, the secret sauce of the technology, the electrochemistry, which blends electrostatic and electrochemical methods of energy storage in a unique way, resulting in boosted energy performance. As I mentioned, we are up to 5 times have up to 5 times higher energy capacity than the supercapacitors, but at the same time remain the fast charging capability and the high cyclability. To bring this technology to the market, we have already built a pretty strong team, I would say. We're currently a team of 12 people based in Mikkeli, Finland, which is a beautiful area of the lake area of Finland. And this technology is supported by also very, very, very strong advisory board. And board of directors. For example, our board includes Michael Everett, who is the ex-CTO of Maxwell Technologies, basically the person who laid the foundation of the industrial supercapacitor technology the way we know it today. So this team is pushing right now towards delivering our first pilots as we gain more and more traction in the target markets, in the beachhead market, as we call it, so the stationary. And recently we signed a conditional offtake agreement with the project developers in Australia for more than 85 megawatts of our batteries to start with, to be co-located with a long duration storage solution. In the future, we will also look into the other segments like the heavy machinery, and in the further development, potentially also automotive. And just as a side note, we are currently fundraising. So if there is anybody who is interested to discuss all of that, I will be very happy to do so. So thank you very much for your attention. I will now stop sharing the screen to be able to see if there are any questions. Oh, right. So I can see some questions. Yeah, so basically, the first question was, I think, let me just check. So how we are different from the flywheel and supercapacitors? As I said, we have higher energy density, and the biggest difference, like on the practical side, is the cost. So I think, if I don't quote me on that, but if I remember correctly, just to produce 1 megawatt of our batteries of our cell blocks is 80% cheaper than that of supercapacitors. And also for the flywheels, we can also offer a very sustainable solution in terms of the sustainability and the price capability. Well, there are a lot of questions coming. Wait, let me just continue with that. So the power and energy density. We are talking. So my apologies. I just have the questions popping up right now. So let me just go here. The calendar life. The calendar life is pretty much as long as we need. So there is nothing which is degrading it. We haven't yet done the exact tests, but so far there is nothing that has been preventing us from saying that the calendar life is going to be somehow interrupted. And in terms of the power density and the energy density, so the power were the same as supercapacitors, and the energy, it's about 15 watt-hours per kilo. And of course, what matters a lot in our case is the volumetric density. What explains your very low price point? Materials that we utilize. Just to give you an example, for the electrodes, we use as cheap as material as carbon black, so we don't need to use any super fancy materials which are going to be sourced from far away. So we can pretty much manufacture and source the materials close to home. And the production method also is low capex, so we do not use any dry rooms. We don't need any drying conditions, and that means that the investment in the production itself is very low. And that's actually also the basic for our future licensing plans, because it's going to be cheap and simple to license the technology. Other questions? Yeah, do you plan to manufacture your battery yourself, or you'll outsource manufacturing? So the plan is that we first manufacture ourselves. So we develop the production technology for our batteries because it's a unique technology, and going to be developing the production solution as well, and going to be manufacturing those in-house. However, in the future, we will be licensing the technology and the manufacturing method, the production method, to other producers worldwide, and they will be able to manufacture the technology themselves at their own home base.
Thank you, Daria. Sorry, I'm going to have to stop you here for time's sake. There were many questions once again.
Yes.
I saw someone ask if you could put your contact details in the chat so that they may contact you by email with more questions that you haven't been able to answer. And thank you so much for your presentation. And I'll move on now to Pierre Hamon-Lapère. When you're ready.
Can you hear me well?
Yes, we can hear you, can see you. Perfect. So Pierre Hamon is the co-founder and CEO of BEPA Batteries, and will present to you what they do. The floor is yours.
Exactly, perfect. Hello, everybody. Super happy to be here. So I am Pierre. I am the CEO and co-founder of BEPA. And at BEPA, we are working on the full life cycle of batteries to understand what is their potential over first life and anticipate their end of life so that we can connect them with the best solution available in Europe. So we are based in Paris. We are a 15-people team operating from Spain to Scandinavia right now, both with OEMs and over 100 tons collected last year. So I guess you are pretty aware of the context, but basically we are electrifying all our vehicles right now, and that poses the massive challenge of what we will do with all those batteries reaching end of life, because of course these has potential value, but we have to make sure that all the supply chain we will build will face the brand new Chinese batteries competition. So this is what on which we are focusing at BIP. And there is a new change because the EU regulation will arrive at the end of this summer, and that will change deeply the way we move batteries around and how they are considered according to the law. So that means it will again increase the cost and make all the battery transaction quite hard to implement when it comes to very concrete action on the ground. So you got it. The big question is, how can we make that circular battery value chain happen? And at BIP, we believe it will only happen if we can make it profitable. So that means we can give end-of-life batteries a real value compared to brand new Chinese batteries, and also compared to the cost of recycling. And to do so, we believe the answer is to bring long-term visibility to actors in that value chain, and also daily help on battery operation so that what we design on slide can really happen. So the first step of this is our live batteries insight. So what we do is we work with EV leasing companies and OEMs to monitor their actual batteries, which are in the EVs right now. So we've built a tech to create SOH reports on the batteries live so that we can monitor over the first life of the vehicle, how it's fading out over time, why it's fading out over time, and even bring value to the OEMs and the EV leasing fleet there. How it works, we've built a remote technology, so we don't need any hardware. So we can monitor hundreds of thousands of vehicles. We have approximately 60% of the EU fleet covered right now. And then we can do like big data on the battery state of health. So today we monitor 20,000 EVs. We can compare the fading of different chemistry. And at the end of the day, this information is super precious for OEMs or any battery owner because they know the state of health of the battery at scale. And they also know where the battery is, in which condition, and what is its value compared to the market. So that brings us to the second part of what we do, which is capturing the end of life of those batteries. So we all know this is a great opportunity, but unfortunately, there is no demand for reuse or for second life right now, which is enough compared to the supply of end-of-life batteries right now in Europe. So the main challenge is to maximize the reuse of batteries. So like EV battery will be reused in another EVs. This is where the value is maximized. Then, if it's not possible, the goal is to repurpose the battery, so reuse it in a energy storage system, for instance, where we can have a value of a battery above €0 per kilowatt hour. And if it's not possible, the question is, how can we lower the cost of recycling? And to give you an insight, we believe like 80-90% of the batteries will be recycled at the end of the day. So this is where the real challenge is, according to us. So we can work on bringing more value on the batteries, and we also can work on deleting all the useless steps in the process so that you lower your logistic cost, you lower your diagnostic cost, and you make your whole value chain management more cost-effective and compliant. So to do so at BIP, we have like a very, I would say, pragmatic approach. We both work with our tech tool, to have the daily approach of battery management. So we put it in a warehouse. It connects all the battery in the warehouse so that we can anticipate where those batteries will go in the near future. And then we've built a global network of partners so that we can address logistic, testing, repurposing, reusing, repair, whatever, on all the batteries. And I came with a very concrete example, one of the hardest we tackled. We worked on 300 tons of LFP batteries for an OEMs that has no value on second life because it's outdated from a technological point of view. So what we did is we took the best 10% of those batteries that could actually make it to second life, and we designed the full supply chain so that the OEMs can really lower its logistical cost and its recycling cost at the end of the day. So I guess that's it for me. What we do, so how we can work together is if you are an OEM or EV battery owner with a lot of challenges on the end of life, we can discuss. And if you want to get a supplier of batteries, of course, we can discuss. And maybe the last point we work a lot on is the ERP compliance. For those of you aware, it will have a huge impact on logistics and battery specification. So we're working a lot on this right now with France and other countries. So if you want to join and learn more about this, more than happy to connect. Thank you very much. And also, I'm taking some questions. I will take it from the end, I guess. Timothée, can you help me on all the questions? I don't know how to
Oh
answer.
yeah, sorry. Sorry. I think if you stop sharing, you will see them, but I can read them to you.
Okay.
So someone asked how you will protect the confidentiality and intellectual properties of battery recyclers, who must not be made to provide a transparent route for very common batteries and downstream, as it could be commercially sensitive.
Yeah, definitely. So this is not public. Basically, what we do is frame contract with OEMs and battery recycling firms. So this is completely protected. And each time we design a specific route for the batteries. It really depends on what happens. So this is protected.
Someone else is asking about your business model, if it's a subscription or something else.
Yeah, so we have two services right now. Either we monitor the battery and if it's a subscription, or either we make a spot transaction. This is what happens when we start working together usually, and then we take a fee on the transaction made.
And there was also a point made on the fact that by October 2026, all batteries will be classified as hazardous, and how you will adapt to that.
So to me, it's still blurry, honestly, because there is a part of the battery that won't be hazardous if you can prove that they still have potential to be reused. So basically, all OEMs, all car scrapyard right now are working on changing it. So that's why I mentioned at the end of my presentation. So to us, it will be a crucial point, definitely, because it will affect the logistic cost, and that's super important. And I think everyone in the battery value chain should be working on that right now to understand it, at least to be compliant and to see how it will affect its business model. So right now we are working with the government to understand it and make sure everything can be compliant. And that also means it will need, again, visibility, traceability of the diagnostics to make sure every battery transaction you do is compliant. That would be super hard to do, basically.
Thank you very much, Pierre-Amand. I'll have to stop you here for the next speaker. You see his email here on the screen for those who have further questions.
Sure.
And thanks so much, Pierre-Amand. And so now we will move on to Azadeh Moteale from Shift Materials.
Thank you very much.
Thank you, Pierre. So Azadeh Moteale is the Chief Technology Officer at Shift Materials, and the floor is yours if you want to activate your camera and microphone as well, and we see your screen.
Okay, thank you. Hello everyone, my name is Azadeh Moteale. I'm the CTO and co-founder at Shift Materials. We are a startup company based in Oslo, Norway, founded in 2023, focused on advanced battery materials, mainly LFP and LMFP. A team of 4 experts working on technical innovations and combining technical excellence with commercialization experience. Our mission is to develop cost-efficient and sustainable cathode active materials for the European battery manufacturers and leverage fresh and recycled materials to enable full material circularity. Our key achievements, first, materials successfully produced. We are at TRL 3.4. Customer validation planned for this year. Financially, we are secured for the next 3 years and actively fundraising to support scaling and growth. If you look at this battery value chain, we are involved in this segment, cathode active materials. Based on the McKinsey report, the European market for LFP cathode material is expected to reach $22 billion by 2030, which shows a huge potential market in the segment. On the other hand, as you know, Europe battery industry is growing rapidly with gigafactories and initiatives planning to produce 2,000 gigawatt hour by 2030. But the supply of essential materials to fabricate the battery cells remain a challenge. Currently, 95% of cathode materials are imported from Asia. It's not necessarily a big problem, but we face a clear challenge here. The current material supply is neither sustainable nor resilient. And this bottleneck highlights the urgent need for locally sourced and sustainable material to reduce dependency on imports. At Shift Material, we aim to address this gap by locally producing LFP and the next generation, LMFP, through sustainable innovation with European technology, reducing the production cost and strengthening Europe's supply chain, and also integration of recycled materials into the process in compliance with EU battery regulation. Regarding the technology, you know that LFP production has a mature technology, but for the LMFP, there is no established standard process yet, except a few Chinese companies who have already commercialized this material. Traditional methods for LFP process are long, complex, and wasteful. They are environmentally unsustainable with high carbon footprint. They require multiple kilns, thermal treatments, which is highly energy-intensive process. Sulfate-based raw materials are normally used in these processes, and they generate excessive waste, and recycling this sulfate waste is costly and also difficult. Our solution is based on one single process for better efficiency and overcoming these limitations. Our technology is based on green chemistry, water-based solutions. We mix all essential raw materials in one single reactor in a single streamlined process. It's a closed loop process with no waste. So we aim to increase the process efficiency by 30%, reducing the production cost by 10%, and minimizing the carbon footprint by 50%. Okay, regarding the team, our leadership team has deep expertise in material science and chemistry. Rune Vendelbo, our interim CEO, has a successful exit experience with the startups. His company, Abalonics, was acquired by IQ Capital in 2021. He was also a former co-founder of Graphene Batteries, which was turned to Morrow Batteries later in Norway. Me, as the CTO with background in material science, ceramics, and additive manufacturing. Mariam, as the CSO, our chief scientist, specializes in green chemistry, material synthesis, and catalyst. We are also looking for another co-founder on business and commercial side to help us with building a strategic partnership and approaching investors. We have also external experienced advisors supporting our strategy and growth. We have an attractive roadmap to become a high-value company. We established this startup in March 2023, and during this period, almost 2 years, we set up our lab facilities, build partnerships, we develop our technology in lab scale. We are now verifying the material performance with potential customers. We have successfully raised 1 million euros through national and European projects and plan to produce 1 kilo per day of prototypes by end of next year. The first significant milestone is to have the pilot production of 30 tons per year by end of 2028. So we need to secure pilot financing and later scale to 100,000 tons per year and full automation by end of 2030. This milestone, of course, will depend on fundings, grants, customer approvals, and market validation. To recap of why we believe we can be a high-value company, local production cuts imports, reliance on a streamlined supply chain. Our technology aligns with the EU sustainability and green energy goals. We will target Norwegian and European multiple sectors, EVs and energy storage applications. Automated production facilitates reduce waste and enhance quality control. And finally, achieving full-scale production. Thank you for your attention. We believe that our technology will make a significant impact on Europe battery industry and green transition. So please contact us with any question. I would be happy to answer. Stop, I think. Okay. This question is for me. Can you comment about your current performance? Actually, we are, as I mentioned at TR 34, we have made this battery test assessment primary in coin cell with the help of some actually partnership with universities, research centers. So we need to have this full cell assessment or more advanced battery test with potential customer, which is not yet done because of this huge amount of the material that they need, almost 1 kilo for testing the material. And reaching this scale is a bit tricky and challenging because we need to adjust multiple parameters in the production process. But the plan is doing this assessment during this year. We are not LFP cell manufacturer, so maybe answering these details or these specific questions could be, addressed by LFP cell manufacturers. But regarding the material itself, it's really challenging for the moment for European manufacturer to be cost efficient and cost competitive with Chinese quality because of the economy of scale. So if we go for that scale, 100,000 per year, for sure it could be cost competitive. But for now, it's a bit challenging. So we try to just develop the process and pre-financing for next years.
Thank you so much, Azadeh. I'm sorry, I have to stop you here. I see maybe a few more questions here, but don't hesitate to reshare your contact in the chat.
Yeah, I will put my email here, and if you have any question, please contact me later.
Thank you so much, Azadeh. I will now move on to Andrew Schwartz, who should also be here. If you can activate your camera and microphone and present perfect. We can see your screen.
Hi everyone. Nice to meet you all. So my name's Andrew Schwartz. I'm VP of Business Development based in a UK-based startup called Florock. We've been active for 3 or 4 years, and we're a venture capitalist venture capitalist funded spin out from University of Oxford. I'm just going to start with a focus and an understanding of fluorine in the battery industry. It's not often thought of as a critical mineral or critical material in the battery industry, but actually it underpins many of the production and performance that you would require to create a robust electrochemical system or a robust battery system. So, for instance, it's the critical cathode binder. It's used in processing technologies for graphite anodes, and importantly, our focus is it forms the electrolyte salt, which is the material that is providing the soluble lithium to be able to shuttle lithium and electrons across the system. LiPF6 is going to be mainly the focus of the discussion today, but actually fluoroc technology extends beyond that, and I'll give a little bit of a focus of that in some of the other slides. So as you can see, fluorine is actually crucial for being able to create battery systems, having robust supply chains, and some of the materials are fluorine-containing materials are directly used in the system. However, the fluorine industry has a bit of a problem. Today, all fluorine is derived from a highly toxic, highly corrosive intermediate called hydrofluoric acid, and actually all derived from relatively high purity minerals that are located in only very few places across the world. So for instance, fluorite mineral of a desired quality is actually only really available in Mexico, China, South Africa, and some emerging into Mongolia. So it's has many supply problems in itself. Hydrofluoric acid is a highly toxic, highly dangerous product that if people could manufacture without it would be highly desired. If you got a centimeter square on your skin without treatment, you would be dead within 24 hours. And this product is made in 2 million tons per annum. So you can see how it has some real challenges. It's also made almost exclusively driven by fossil fuels, so again has a relatively poor sustainability elements associated with it. This is where fluoroc comes in. Fluoroc completely reinvents the fluorochemical process, and for the first time we can take fluorite minerals and fluorine-containing materials and directly produce fluorochemicals through our innovative new process. This process was developed over a 5 or 6 year period within the university, and then fluoroc is a vehicle to commercialize and use mass market for the product. The technology itself is based on a very innovative mechanochemical activation where you have abrasion and shear affecting the two materials that create a new intermediate, and then that intermediate can be used to make the downstream fluorochemicals. Importantly, we also don't rely on the high purity, high grades of raw materials that are required in the HF industry. So it really opens up that supply chain and means that the availability of fluorine becomes more of a mass market rather than concentrated in certain regions and with certain companies. Our platform can be applied on almost any fluorochemical downstream, from polymers to gases to agricultural and pharmaceutical products, but we've chosen to focus on battery materials, really due to the growth and the demand in the marketplace for materials. And very specifically, we focused on this material here, which is LiPF6, which, as this is a battery audience, probably doesn't necessarily need to be explained too much further. Our technology to produce this product has now got to TRL6, and we're looking at that next stage of scaling up and industrializing the technology for mass market production within a European context. The technology itself has certain benefits. Because of the flexibility in the supply chain, we can use much lower cost materials. And that, according to our calculations and independent third-party techno-economic assessments, leads to a 25% cost saving for production. Our technology is based on more like milling, grinding type processes that you would see in the paints industry or the mining industry, rather than the highly specialized, highly hazardous production you would see in the HF and fluorination industry. So we don't need to use pressurized reactors because hydrofluoric acid is a gas. We don't have to use special materials of construction because it's highly corrosive. And that leads to very, very significant lowering of capital costs, up to 75%. Our technology is fully driven by electrical energy rather than fossil fuels. So you get some really deep improvements in sustainability and CO2 emissions. And for the first time, we can utilize waste products from other industries that contain fluorine, which again further reduces the emissions, and actually for the first time starts introducing cyclic economies for fluorination. We also see this as a real enabler for electrification and the drive of the battery industry within a European context. Today the main product, LiPF6, is 95+% derived from China, whereas the technology that we're developing and the new manufacturing that we will put in place really enables Europe to create a localized industry with localized supply chains. So what we're really looking for at this stage is partnerships either with downstream producers of electrolyte materials who would be interested in looking at our products, or people, co-producers in the value chain, either downstream or in the same level or upstream, who'd be interested in developing projects or developing grants to help with that next stage funding for our industrialization of our technology. I think I have a few minutes left for questions. So if I stop sharing, maybe I can have a look at the questions that are listed. Can we make other metal salts? So yeah, our technology is directly applicable to making sodium PF6 as well as lithium PF6. We've chosen lithium PF6 because this is the marketplace today, but the same process would make sodium PF6. We don't need to take feedstock from Mexico. So there's a reference here that a lot of fluoride is mined from Mexico and imported into the European system. We don't need to take a feedstock from Mexico. Actually, there's a lot of fluorine-containing waste products that are put to landfill within a European context. Actually, we believe for our business we'd be able to use those almost exclusively to produce all the LiPF6 or sodium PF6 or LiFSI that you would require. PFAS, there's a question about PFAS regulations. I promise this is the last one, Timothy, and then I'll be quiet.
It's okay. We have a little bit of time, and I'll just quickly conclude the meeting anyway. So if there are more, you can maybe take a minute or two more.
Okay, great. So there's a question on how we associate with PFAS regulations. So we don't make PFAS. So PFAS is polyfluorinated carbons, essentially, whereas where the surfactants are the really problematic ones because they can get into the watercourse and then into biological systems. The products we've been targeting so far have either been single carbon fluoride products, which would degrade under ambient conditions, so they don't fit the PFAS regulations, or they're inorganic salts like LiPF6. And if you have any exposure to the atmosphere, again, it degrades into products that would go through abatement systems and waste systems. So PFAS doesn't touch us. Actually, one of our founders is Veronique Gouvener, who's a world-renowned professor in the fluorination industry. She's actually just developed a new technology for processing PFAS waste using similar technology as ours. And if anyone's interested in that, please reach out because we have some technology in that area we'd love to talk to you about. I'll close out there because there are no more questions. Thank you very much.
I don't see any more questions either. Just some AI comments. Not sure how we can avoid those, but that's okay. Thank you so much, Andrew. Maybe as a last point, I'm not sure I saw your email in your presentation or contact information. Yes, as is being asked in the chat, if you would like to directly share that in the chat at your convenience, of course. So that people may contact you directly. Great. So thank you everyone for coming into this webinar. This is now the end of today's edition. I'd just like to remind you quickly that next month, on the 18th of June this time, there will be another edition with 5 more startups that you can already see a preview of right now. So normally one of my colleagues should already put the link for registration in the chat, but in any case, we will send you a follow-up email with all that information presentation today or tomorrow, and which will also have a recording of today's meeting if you want to share some of the things that you saw today to any partners or collaborators that you have. So we look forward to seeing you already next month for the next one. And enjoy your lunch if you haven't already had it during this webinar, and have a good rest of the day and of the week. And we'll see you next time. Thank you again to all the presenters, of course, and for participating to this first edition. And we hope to see you again in other circumstances, of course. Thank you, and goodbye, everyone.